Hello and welcome to Forrester High School Maths Department's National 5 Maths Support Materials. My name is Mr. McDonald and I'll be talking you through your topics today. Today's learning intentions are to be able to find arc lengths and to understand circle terms such as arcs, sectors, and internal angles. So what's important to start with is that you understand some circle vocabulary. So on the left-hand side circle, these are the terms that you should know from National 4. Hopefully you know that the radius is a line that goes from the center of the circle out towards the outside of the circle, and it touches the outside edge. The diameter goes from one edge of the circle through the center to the other edge of the circle, and then the circumference is the distance all the way around the outside of the circle. And these three terms are important to understand for National 5 as well, because there are a few things that relate to these three pieces of information about a circle. In terms of National 5 vocabulary, what we have here is we've got a sector. Now that is an area. So the sector is all of this area here in green. There's an arc, which is the outside edge of a sector. So part of the circumference of a circle is called its arc. And part of the area of a circle is called its sector. Today we're going to focus on arc lengths, and tomorrow we're going to look at sector areas. It's important to note that although we're talking about arc lengths and sector areas, we have some important information contained in this sector. The edges of the sector are the radius of the circle as well, because those are lines that go from the outside edge of the circle to the center of the circle. Okay, so just to introduce you to a quick formula, the arc length formula starts with AL for arc length, and it is equal to the Greek letter theta over 360 times pi times the diameter. Now you'll notice on the side here that I've got that that is related to the circumference formula. You'll notice that the circumference formula is pi d, and this equation also ends with pi d. In fact, the only thing that is different is the angle over 360. And that is because the arc length is just a fraction of the outside edge of the circle. It's just a fraction of the circumference. So arc length is equal to some fraction of the circumference. This term here, theta at the top, is a Greek letter that just means angle. Don't worry too much about that, it just means angle. And that is the internal angle of your arc length. Okay, and I'll show you a little bit more about that in just a second. Okay, so here's a quick example of how an arc length question might look. On the left hand side here, we've got a sector of a circle, that's just part of a circle, with an internal angle of 225 degrees. So I'm going to highlight that, and I'll highlight the part of the equation that that matches to. So theta, the internal angle, is equal to 225 degrees. We've also got that the radius of this circle, the distance from the center to the outside, is equal to 5 centimeters. And I'm going to note down that that is the radius of the circle, because as you can see, we're not asked for the radius anywhere in our formula. We're actually asked for the diameter. Okay, so that yellow highlighted 5 centimeters relates to the diameter, and we're going to use that to figure out the diameter very shortly. And the arc length is what we're looking for. That's the distance all the way around the outside of this sector until we get to the straight edges of the radius. Okay. Right, so to figure out this arc length, the first step that you have to take is to write down the formula arc length is equal to theta over 360 pi d. The next step is to put in your numbers. So instead of theta, I'm going to write down 225 because that's my internal angle. 360 is always on the bottom of the fraction because all circles, when they're full, have 360 degrees all the way around them. we're going to write down pi, but if you don't have a scientific calculator and can't use pi, then use the approximation pi is equal to 3.14. If you do have a scientific calculator, use the pi button on that. And then we're going to multiply that by diameter. Our radius is 5 centimeters, so our diameter is twice that size. It's 10 centimeters. Okay, and again, that relates to that highlighted section in yellow. Okay, we got our diameter being 10 centimeters because our radius is 5 centimeters. The diameter is twice the size of the radius. If you put all that into your calculator with the pi button, you get an answer of 19.63 centimeters. If you use 3.14, you get a slightly different answer, but that's just because you've rounded to less decimal places than the calculator's pi button uses. Okay, and that's how it's done. 2 pieces of information inserted into the formula, and then a bit of calculator work to help you out in the end. Okay, so here's the second example. I'm going to do this one a little bit quicker. I'm not going to talk through quite as many things, and let's see how that goes. So I'm highlighting the internal angle. That matches with this theta here. And this time I'm being told what the diameter is, so I don't have to think about changing it from radius to diameter. It's already given as the diameter. Okay, so I've written out my formula. Second step is to write out my inserted numbers. So instead of theta, I have 110 degrees over 360. That's being multiplied by pi. I'm going to use the pi button again. And it's being multiplied by 8. So our final answer for this one, if we all put it into the calculator, is 7.68 meters. Got to get your units right, to 2 decimal places. I would always recommend rounding to 2 decimal places. If you can give your unrounded answer first, that's always great. A little bit extra detail, and then round to those 2 decimal places for your final answer. I'm just going to put 2 dp down here. I hope you're a little bit more detailed than I am in your working in your assignment. Okay, so here we have one more example, and you'll notice there's something slightly different about this one. This one we are not allowed to use a calculator for. This is something the SQA always checks on in the National 5 exams, or at least for the last 3 or 4 years they've checked upon this, that candidates can use this formula without having to use a calculator. So in this example, we're going to use pi is roughly equal to 3.14. Okay, we're going to use that approximation because any more digits of pi, and we're giving ourselves far too big a task here. Okay, normally in the questions that the SQA will give you, it will say use 3.14 instead of pi for this. So if I'm writing out my second line of working here, I'm going to put in my internal angle, which is 300. Over 360 pi, and then my diameter is going to be 12. That's double the 6 that I've got as my radius in the diagram here. Okay, so just to mark that up, highlighter pen. I know this is probably far too much information for you, but just in case people are wondering where this is coming from. So the 300 is theta, that comes from there, and then, oh, that doesn't look like a different color, but never mind, that's 6 centimeters, and that 12 centimeters of length as well. Okay, so how are we going to complete this without using a calculator? The first step, and the most obvious step to make this simpler, is to simplify that fraction at the start. So if I think about what divides into 300 that also divides into 360, I can get this down to 5/6 times pi times 12. Okay, I'm still not very happy about having to do 5/6 of pi, but if you know that actually things that are multiplied together can be multiplied together in any order, then this becomes a little bit easier, because what we can do is we can do 5/6 of 12. Now I know that 12 divided by 6 and then times by 5 is equal to 10. I'm going to change that pi to 3.14 because I've been asked to use 3.14 instead of pi. And actually, 10 times 3.14, dead easy. That's 31.4. All I have to do is move those numbers over the decimal point one place to the right. And my units, centimeters. Okay, and it's as easy as that. Just make sure that you simplify your fraction fully, and then use that fraction and the diameter to come up with a whole number that you can then multiply pi by. It won't always be as easy as multiplying by 10, but you should be able to use chimney sums to come up with an answer without using a calculator. Okay, so very well done for getting to the end of this video, Nat 5s. Remember that your assignment is due on the day that is given to you. Remember, you can ask questions to me through Show My Homework or through the email. My email is craig.mcdonald@forrester.edin.sch.uk. And remember, you can do it. Okay, give it a shot, ask me questions, and if you have to do it more than once, just be patient and do it more than once. That's okay. All right, well done for getting through this video, and best of luck in your assignment.